Hello everyone, I am Dr. Subhasish Saha, Assistant Professor in Physics, Department of HNS, MLR Institute of Technology, Hyderabad. So today I will discuss about preliminary idea about the quantum physics. So today's topic overview is wave particle duality, de Broglie hypothesis, matter waves. So these topics we will cover today, and Heisenberg uncertainty principle. So first come to the introduction section. What is quantum physics or quantum mechanics? Quantum mechanics is a mechanics or physics which introduce the concept of particle nature as well as wave nature. Means basically it introduces the concept of dual character of a material particle such as electron, proton and atoms, etc. Now, what is wave and particle? Particle is a fundamental component of all matter waves, all matter in universe. So when you're talking about the particle, so definitely it has some position and mass. When you apply some external force, it may gain or lose energy and it can move from one place to another place. Thus it has position, mass, velocity, momentum, energy. So these are the fundamental property of a particle. Now when you come to the about wave, then wave is a periodic manner in a medium or in a space. So when you are talking about wave, so wave is actually spread out over a region of space. It does not have any specific position or mass. Wave is specified by its speed, frequency, wavelength, amplitude. So these are the fundamental properties of wave. So in case of particle, it has some definite mass, position, velocity, momentum, energy. But when you're talking about the wave, it is spread out over a region of space. So it has not a specific mass or position. Rather than it can be described in terms of frequency, amplitude, wavelength, speeds with those parameters. So these are the properties. Now the thing is, when you're talking about wave and particle nature of any matter, so the question is coming, wave and particle duality is there or not? What is wave particle duality? So wave particle duality is, suppose in case of particle like electron, photon behave like waves. Okay, according to Planck's quantum theory, which correctly explain the black body radiation, photoelectric effect, Compton effect, in which radiation interact with the matter in a form of photon, which demonstrate that radiation behave like a particle. So some of the experiment actually confirm that the radiation will behave like a particle. Those are black body radiations, which was not classically explained in those days, but when the Planck's quantum theory give the correct explanation how to describe the energy distribution of black body radiation, then later on in photoelectric effect, when actually the photon interact with a metal surface, electrons comes out, this photon also treated as a particle, then only this can be explained. In Compton effect, it will also nicely explained when it's treated as a photon will be treated as a particle. So these experiments confirm that the radiations will behave like a particle. Photons have to act behaves like a particle. Now on the other side, some of the experiment like double slit experiment correctly describe the interference and diffraction effects. Okay, in those phenomena can be explained only when two particles are in the same position at the same time. Okay, which is only possible when the particle is treated as a wave. Okay, this means if these particles cannot, we know the particle cannot occupy the same position at the same times. So to explain the interference phenomena, diffraction phenomena in double slit experiment, we have to know that the waves can be superposed and they can propagate in the space and they can superpose. So at a particular time, the two waves can be occupy the same position at the same time. So it is only possible when it should be treated as a wave. But both of the properties like wave properties as well as particle nature cannot be observed simultaneously from the same experiment. Okay, so it introduced the concept of complementary. Okay, so this is some idea about the wave particle duality. Some particle to explain some of the experiment. In that cases, we should treat it that the photon or radiation will be behave like a particle. In some experiment, they have mentioned that when it treated as the wave, okay, when the particle should be treated as a wave, then only those experiment can be explained. But both of the properties cannot be measured simultaneously. This is a wave particle duality concept. Now later on in de Broglie in 1924 hypothesized that particles such as electron could exhibit wave-like properties. Okay, this was experimentally confirmed in Davison-Germer experiment in 1927, which showed the diffraction of electrons demonstrating their wave-like behavior. So this means what de Broglie hypothesis? What is de Broglie hypothesis? De Broglie hypothesis mentioned that in some material which contain atoms, in which the primary elements are electron, protons, if those are treated as a particle and when those are moved inside this material, those particle is associated with some wave. That wave is called matter wave. Okay, and from Davison-Germer experiment, it was shown that this electron treated as a wave. Okay, that wave is called matter wave. From the diffraction pattern of those electrons, actually describe it can be behave like a wave. Now come to the details in de Broglie hypothesis. What is de Broglie hypothesis? According to de Broglie concept, a moving particle has a wave associated with it and the motion of the particle is guided by that wave. Okay, so this means when a particle moves, okay, then a wave is associated with that particle and the motion of the particles can be guided by that wave. Okay, that wave is called matter wave because the waves is associated with a material particle are called matter waves. Okay, so this is matter waves concept. Now what is the mathematical expression of de Broglie hypothesis? The wavelength of matter wave is given by lambda equals to h by mv equals to h by p. So h is lambda is the wavelength of that matter wave, h is the Planck constant, m is the mass of that particle, v is the velocity of that particle. So p equals to m into v, that is momentum of that particle. So this means I mentioned about those things. Now derivation of this de Broglie wavelength. Considering a photon as a particle, okay, when it's treated as a particle, what is the total energy equals to mc square, where c is the velocity of that photon. When the photon treated as a wave, then the total energy equals to h nu, where h is the Planck constant, nu is the frequency of that photon. Now we compare equation 1 and 2, we get that h nu equals to mc square and the just use the momentum expression p equals to mc. So if you just substitute p in place of mc, then we can write h nu equals to pc. From there we can get lambda equals to h by p. So this is the wavelength of a photon where p equals to mc. Now this expression can be used for any other particle instead of photon, like electron, which are moving inside a material. Okay, so in that case the momentum we can write p equals to mv, where v is the mass of that particle, which in case v is much less than c. So v is the velocity of that particle associated with the matter. So this is the expression of de Broglie wavelength. Now come to the next. What is the de Broglie wavelength in terms of kinetic energy? So we know kinetic energy equals to half mv square, and we just little bit modified in this way, we can write this E in terms of momentum. Ek equals to half mv whole square divided by m, and mv equals to p, so it is basically p square by 2m. So p equals to root 2m ek, and substitute this p value in this expression where we can get lambda equals to h by root 2m ek. Ek is the kinetic energy of that particle. Now kinetic energy can be expressed in terms of potential. Suppose a particle having charge q is accelerated with the help of some electrostatic potential energy, that is V, then we can write Ek equals to q into V. Then we just substitute the Ek value into this equation, and we can get this form, lambda equals to h by root 2m qv. Now we substitute q in place of q. Suppose the particle is electron, then I can replace q equals to q in place of q. We can substitute E, and then we can just substitute all those values. H values, Planck constant values, m is the mass of electron, E is the charge of this electron. We shall substitute all those things, and you can find the lambda in this expression. It is this angstrom order. Okay, so this is express the lambda value in terms of kinetic energy. Next is concept of uncertainty. Before going to the discussion about Heisenberg uncertainty principle. So first, from where the concept of uncertainty came. So we know while the particle is confined to a particular region at any time. Okay, when the particle is confined within a region of space, okay, the matter wave associated with that particle has some spread, as it is a wave. Okay, so when the particle is treated as a wave, it has some spreading over a region of space. Okay, when it is treated as a wave, it has some spread is there. Since the wave is spreading over a region of space, thus the wave nature of matter introduces an uncertainty in the position of the particle. Okay, so and we know that the wavelength is inversely proportional to p. If position is, a wavelength is the order of length, and those are reciprocal to each others. If it is treated, when the particle is treated as wave, that is uncertain in the position because of their angular, there is spreading over a region of space. There is a spatial spreading is there. So since position is uncertain, momentum is also be uncertain, which introduce the Heisenberg uncertainty is the based on this concept. Okay. Now what is Heisenberg uncertainty principle? First, there are two ways we can give the statement. First statement, we can write that it is not possible to simultaneously measure the position and momentum of a particle, okay, to any desired degree of accuracy. So both of the quantity, position and momentum, cannot be measured simultaneously. Those are canonically conjugates. Okay. In other words, we can also mention the product of uncertainty in the measurement of position, which is called delta x, and the uncertainty in the measurement of momentum, which is delta p, is always constant. This means uncertainty in the position and momentum, it is already written, uncertainty in the position and the momentum, product of these two quantities always give you some constant value, that is h by greater than equals to h by 4 pi. Okay, or h we can write h cut equals to h by 2 pi, reduce Planck constant. So this is the Heisenberg uncertainty principle concept. So today's discussions was what is wave particle duality, what is de Broglie hypothesis, and what is Heisenberg uncertainty principle. Okay, so in next video we will discuss about Schrodinger time independent wave equation, particle in a box problem, physical significance of wave function, postulate of quantum mechanics, introduce the concept of operator in quantum mechanics. Then we can give some idea about eigenvalues, eigenfunction, expectation values in next video. Thank you.